Hello and welcome to this episode of the Primary Maths Podcast, the show where we talk all things primary maths with me, John Cripwell. Today we're talking about something that sits right at the heart of great mathematics teaching: variation and task design. I'm delighted to be joined by John B. He works as a maths advisor for a large multi-academy trust and is the author of the brand new book, Teaching Maths for Mastery, which I have had a copy sent to me this week, and I've only just had a chance to flick through it. I was explaining to John before we started, it's been such a busy couple of days with the curriculum and assessment review and things landing, but I'm very much looking forward to getting stuck into that later. John's had a range of leadership roles in education. He holds a master's degree in education as well, with a math specialism, and he is, like myself, a primary mastery specialist as well. You can find out more about him on his website, mrbteach.com, where he shares resources and reflections to help teachers bring mastery principles to life in the classroom. In this episode, as I mentioned, we're going to dive into how variation theory can shape effective task design, what it really looks like in practice, and how teachers can build pupils' understanding through purposeful sequences of examples. So, John, welcome to the podcast. I am delighted to have you here.
Thank you so much. Wow, what an introduction.
Well, all very deserved and hopefully all factually correct. I normally manage to do that little bit of the homework. So, John, I normally like to start with just asking all our guests, what was maths like at school for you? Was it a favourite subject or something that you try to avoid?
Do you know, actually, when I look back, it's not something I really have a great deal of memory of, John. It's one of those, what I do remember is being told that I was good at maths, but actually I don't really know what that meant in practice. I just remember my mum and my dad saying, you're pretty good at maths. Teacher almost mirroring that, and that's about the extent of my memory of it. I don't remember how I was taught to become fluent with maths facts or procedures. I don't really remember being taught to reason or to solve problems. I'm sure I did at some point, but there's no real core memory other than I was told that I was pretty good at maths.
It's interesting, isn't it? I wonder whether... So I was talking to another guest earlier today, and she'd had a very different experience of maths at school, a little bit, but before your time, I'm assuming, John. Her education was more in the 70s into the early 80s. And she just remembered working through textbooks. Again, didn't remember a huge amount of actual teaching. And when I think about my education in the 80s and early 90s, I don't remember a huge amount of actual teaching either. It all looks very different now, doesn't it?
And for the better, hopefully, yes, absolutely. I think we've done, over the last 5 to 10 years, our thinking has really shifted on curriculum and what that looks like and what effective curriculum looks like in individual schools, and also how curriculums can be adapted for the cohorts of children. I often use a phrase when I'm supporting schools or staff or maths leads about teaching to children's stage rather than age. And there's a danger, isn't there, that even though you are the year 5 teacher, if you only deliver the year 5 content, but the children are not necessarily ready for that content, then we're really building on sand. So I think one of the core messages around that is to make sure that we're tracking back and building concepts up. I think another aspect of that, John, is that pedagogy has changed fairly significantly. Even in my 15 years of teaching, I can remember turning up to a classroom fresh out of university, and I'll cringe when I say this out loud, but it was an observation lesson, and I really wanted to blow the observer away. And so I, in my infinite wisdom, had decided I would sellotape some calculations onto the front of balloons. And when the children were answering, the children would pop the balloon, and the answer would be inside. And of course, the children had a great time. So did I, to be fair. But did they actually learn anything mathematically that they couldn't do before the lesson? Absolutely not. And the observer was very complimentary at the time, thought it was a great lesson. But I think our definition now of great lessons has changed, and it doesn't exist really now. A great lesson, actually, what we mean is effective teaching and learning. So I think there's been a whole shift in emphasis on kind of math teaching in general, and hopefully wider than math teaching.
Yeah, no, I totally agree. One of the things that has been nice, just on that point, one of the things that has been nice to observe are some of the principles, though, that might have started in maths teaching actually sort of flowing out into other areas of the curriculum when we're thinking about teaching for mastery. And obviously, your book is teaching maths for mastery, but I think we're hearing more and more about this idea of teaching for mastery going into other areas of the curriculum, and that's really interesting, and I think a positive thing to hear. But you're right. I can remember when I started teaching under the previous curriculum, where we still had levels and things, and I was in year 5, was my NQT year, newly qualified teacher year as it was then. And I remember having children working at P levels, so below level 1 as it was, all the way through to sort of a level 5, and trying to differentiate different tables, doing different tasks, completely different lessons really going on within the classroom. We've moved quite a long way away from that now, I would suggest. Are there still children? Is everybody working at the same level as each other in the classroom now? No, definitely not. And COVID's not helped with that, I would suggest. But there's always going to be differences in how children are learning, aren't there? So now the conversation is much more around scaffolding, isn't it? Scaffolding so that we can enable all children to try and keep up. And then thinking about how we can stretch those children who maybe are higher retaining, or potentially, without moving on to new concepts. So it's a different skill, isn't it, in some ways, to how it was maybe 15 years ago.
Absolutely. And I think there's a couple of things in that, John. I think the first thing that struck me about what you said there is this emphasis on keeping up rather than catching up. And you're absolutely right. Being able to scaffold children's learning of particular concepts is really the key. But alongside that, and what I tend to find, particularly in the primary space, is often subject knowledge across so many different areas of the maths curriculum will undoubtedly be stronger in other areas. If you think of, primary teachers who, all of them will be teaching place value, addition, subtraction, multiplication, division, and fractions to a good amount of depth, but actually their knowledge of other areas of the curriculum mightn't be as developed as. But also with that, if you are, as you said, the year 5 teacher, is there an understanding there of where children have come from and how the concepts build? I work in various different contexts where in some cases I can see that teachers are highly skilled and know how to track back and to build concepts. So there's that equitable offer for all pupils. In some cases, I see teachers who just deliver the year group appropriate content. And I think that needs to come with a bit of a health warning. Again, just to repeat that phrase, we're teaching the stage of the children rather than the age of the children. Even if, you are working at the expected standard or you're developing depth within understanding, it often doesn't do any damage to go back and revisit some previously taught concepts in maths, so that again you're really strengthening the understanding there. And that point on differentiation, absolutely. I remember exactly the same, John. Those 5 different ways of differentiating. You're sitting working with the purple group. Meanwhile, the green group are off task, but you can't really remember what they were meant to be doing because you're so focused on your group. And actually, looking back, it was just chaos, planned chaos. Whereas now, teachers are encouraged where possible to teach one thing, to teach it well, to build that concept over time. And as well, you touched on this idea of depth. And I think there's a bit of a danger that we use the term greater depth in primary because it is a measure at the end of Key Stage 2. And it only occurred to me fairly recently that when I say depth, I actually mean something completely different to, I think, probably what most interpret. So when I say depth, I think that should be for all children, because of course you want all children to understand mathematics at a really deep level.
It's interesting, isn't it? Because uh, after year 5, I moved briefly into year 2, and then most of the rest of my teaching time I spent in year 6, because once you end up in year 6, it's very hard to escape from there. And I never really wanted to anyway. I love teaching year 6. But that idea of greater depth, although that isn't a description that's used by the STA or the DFE, they talk about attaining the sort of the highest standard, don't they, within the age related expectations. But essentially, to achieve that in the Key Stage 2 tests, that score of 110 or more in a scaled score, it's just about being accurate in the time frame that you've got, isn't it? It's not about doing. So if I think back to the previous curriculum, we would have a separate level 6 test for some children who we thought would be able to access that, and that would have a completely different set of content within it. That's not the same anymore. In order to get that higher level at the end of year 6, it's just about answering all of the questions, or most of the questions, accurately and quickly, which probably does reflect that level of depth that you're talking about in terms of being confident and working accurately and efficiently, and being able to solve a range of problems based on Key Stage 2 content, not just the year 6 content even.
Yeah, absolutely. And I think, when you unpick the content domain and the year group um, assessment, kind of where the assessment sits, around about 50% of it is from year 3, year 4, year 5,
Yeah.
50% being roughly from year 6. So actually, not that we do things for SATs or any other kind of measure, um, but actually, if that's how the SATs are put together, it makes good sense for the year 6 teacher to then be tracking back to year 5 content, year 4 content, year 3 content. So that's what I meant when I was saying, in some cases, teachers in year 4, 5, and 6 may well feel like they're more of a Key Stage 2 teacher, because
Yes.
they're constantly referring back to the foundational knowledge to secure really strong foundations for all children.
And also, as you alluded to earlier, if you are doing geometry for 10 days out of the whole school year in each year group, that isn't sufficient, is it? I can't remember what I was doing last week, John, let alone what I was doing 6 months ago in a lesson that I was half engaged in and not necessarily fully paying attention to. So that retrieval and making sure that we're bringing things back out of our memory, and applying them again is crucial, isn't it? Just moving into the topic that we suggested we talk about. I'm terrible for going off on tangents, so I apologise, but I do think it's all relevant actually to what we're going to talk about. Would you mind just introducing the idea of variation theory? It's probably something that a lot of teachers have heard of. It's one of the 5 big ideas, according to the NCTM, for teaching for mastery. One of the 5 big ideas of teaching for mastery would be variation. What do we mean by variation, and what does it look like?
Yeah, and I think quite often it's the one that is the most misunderstood of those 5 big ideas, the one that takes really careful thinking to get right, and is easy to get wrong. So straight off the outset, What variation theory isn't is variety of lots of different things. And I often hear members of staff, colleagues talking around variation as just being lots of stuff or lots of different representation. Actually, we know that that can be quite unhelpful in maths lessons and can often lead to confusion if you're showing the same concept in 6, 7 different ways. So really the idea of variation theory is to drill down into the essential and non-essential features of a particular concept. And it links with, and listeners might have heard the phrase intelligent practice. It links with intelligent practice, and really it comes from Professor Gu from the University of Shanghai, who talks about teachers designing careful sequences of questioning for procedural variation that avoid mechanical repetition, but actually create a really careful path for children to practice the thinking process with increasing creativity. Now, that's a sort of, I suppose, big, broad overview. If I was to boil that right down, I would say there's 2 different types. So the first type of variation would be conceptual variation, and the second type would be procedural variation. So we'll take those in turn, and I'll just kind of guide you through a whistle-stop tour of what variation theory is in terms of conceptual. So we see this all of the time in a non-maths concept. So, just so I'm kind of on brand, let's talk about bees for a minute. So if you were to imagine a bee, you're probably imagining a small insect. It's yellow and it's black. And so on. But of course, when you drill down into the actual specifics, there are lots of different species of bees. There are bumblebees, there are honeybees, there's a tree bumblebee, a carly bumblebee, and they all have subtle differences. But actually what they share what is it that makes them a bumblebee and not a different type of bumblebee? Now, stick with me with this metaphor, because actually, when we apply that to a maths concept, in the early years, Key Stage 1, we may well be teaching children what a triangle is, but also what a triangle isn't. And so we might arrive at a generalization that a triangle has 3 sides, 3 vertices. And so we need to show children equally what a triangle is, but importantly, we need to show children what a triangle isn't. And we can make sure that we show representations when we're developing the concept that isn't always an equilateral triangle, that isn't always a right angled triangle, because what we show children, they will learn, we hope anyway. But if we only show them particular concepts in particular ways, it stands to reason that they will always think that that's what a triangle looks like. So actually non-examples with, a shape with 3 sides, but one of the sides is not quite complete, well, then we tighten up their generalization to explain that, well, a triangle needs to be a closed shape. It's a 2D closed shape with 3 sides and 3 corners. We might then develop that a little further to show a triangle with 2 straight sides and a bit of a wavy side, or a curved side, so that children know that the 3 sides have got to be straight. And the implications...
And all of these are opportunities, aren't they, John, for developing not just the conceptual understanding, but also the talk and the vocabulary around it. And without having those conversations, those things won't become internalized, will they?
Absolutely. It's absolutely imperative that this is part of the conversation. And, from the early years, Key Stage 1, just simple sorting activities, triangle, not a triangle. If it's number, for example, is it 6 or not 6? Just different techniques that can be used to build a concept. The implications for this, John, in Key Stage 2 are that there are lots of different types of triangles. So children will learn that triangle can be equilateral, isosceles, scalene, right angled isosceles triangle, and so on and so forth. And so that type of variation, that concept, they're all triangles, but actually they look widely different, takes us right back to that bumblebee analogy. And yes, they're all bees, but actually there's lots of different varieties of bees. And we can apply that to things like, I remember when I taught in year 6, I showed children what looked like a 2D image of a house, and they described it as a house rather than a hexagon. So really, when we're drilling down to that concept, we can say they probably weren't as secure as we might have liked for conceptual variation.
And that makes so much sense. And the reason, as you say, for doing it that way is that we're encouraging children to notice things more as well. And when you notice things for yourself, rather than just being told this is a triangle, it's a much firmer and much stronger bond that you have with those connections. I know that this is a triangle because not just because it's got 3 sides, but actually it's got 3 straight sides. It's a closed shape. Also showing, I always think of triangles, we often tend to show them in one particular orientation, where it's wider at the bottom and narrower at the top, potentially. The fact that there's no such thing as an upside down triangle, it's a triangle, whichever way you put it, it is, it's a misconception that is easy to unpick, but if it's never done, if you're not thinking about those potential misconceptions, then it won't happen. It's the skill of the practitioner, isn't it, in thinking ahead to what are the potential misconceptions and how can we draw children's attention to that through the variations that we might show them.
Absolutely. And I think you've hit the nail on the head there. It's really about teachers knowing what they want children to notice and having that at the forefront of their thinking. Because we can all show, lots of different triangles on the board, but in a way that can easily slip into variety. That's rather than showing 2 really carefully selected triangles, if we stick with the triangle theme, showing 2 carefully selected triangles and actually teasing out of the children what is the same and what is different. Now, if teachers have found themselves asking that question, what do you notice, what's the same and what's different, there's a good chance that they've used a type of variation, whether they have realized it or not. And lots of well-known published schemes out there do already include variation, but it's quite easily missed if we as teachers are not alert to what it is that sequence or that concept is trying to expose.
And it can be tricky, can't it? What might procedural variation look like? What's the same and what's different?
Okay, so procedural variation often occurs within the process of doing mathematics, and the characteristics of procedural variation are that there is a slight change each time. And I'll illuminate this with a few examples as we kind of talk through. As I said right at the beginning, it often links to children practicing the thinking process, but in really creative and imaginative ways. And I think before we set off around kind of procedural variation, we need to think about a few different things. So the first thing we need to think about is, what is it that we actually want children to notice, to know and remember? Which methods are children likely to use or not use? Where actually might pupils fall down? Where might misconceptions arise? And how can we help pupils make connections? And for me, that's the biggest advantage of using some procedural variation. So let me just give you an example of how we might get children to make connections with a bit of procedural variation. I'm going to start with 5 times 3 equals 15. So I want you to imagine that in my class, I've got that up on the board, and I'm just teasing out with the children kind of what the product of those 2 factors would be. We arrive at the fact that 5 times 3 is 15. So in the next question in my sequence, I'm actually going to switch those factors so that we've got 3 times 5 equals 15. And so I'm going to ask the children what's the same and what's different. So in the back of my mind, between those two questions, I've asked the children what's the same and what's different. I'm looking for them to tell me when the factors change, the product remains the same. Because multiplication is commutative. So this is what we mean about those deep structures that are sitting underneath. Now, the teacher has got a decision to make. So we're now at 3 times 5 equals 15. Now, one of the, I suppose, pitfalls of teaching with procedural variation is there are so many different ways that you can take it, and there's no silver bullet to say this is how it should be done. If it were me, let's say I then want to develop the children's understanding of perhaps timesing by 10, 100, 1,000, or dividing by 10, 100, and 1,000. Perhaps the next one could be 3 times 50 equals something. So because they know 3 times 5, they're making that connection to 3 times 50 equals 150. So then it stands to reason that perhaps the next one, my next decision might be, well, do I just swap the factors this time to check that they can do that with greater numbers, or actually, am I going to do something else? Now, because children might be starting to pick up on the connection by the third question, perhaps you want to put in a bit of a cognitive shock. Now, Professor Gu, as I said right at the beginning there, talks about not just working through mechanical kind of sequences of questions. So perhaps a bit of a cognitive shock here could be something along the lines of 3 times 0.5 equals, and then using the connections between the previous questions to sort of guide the children to getting that product. What we're not teaching children how to do, or may not have taught children to do yet, is to multiply or divide by decimals, but they can use logic through the procedural variation to work that out. Now, what you can then do after that small cognitive shock, so we're at 3 times 0.5 equals 1.5, we might actually change the whole domain of maths, and maybe we want to draw attention to 3 times a half equals something. So then children are making that connection between 0.5 and a half. Now, we're only 5 questions in, but you can see the depth of understanding and how deep that can go quite quickly. And there's so many different ways to do it. I mean, another way that I've done that is to actually stick sequences of questions, for example, with times tables, in children's books with the answers already in. And actually, their task isn't to work it out, it's to almost reason and explain where the connections are and why they think I've designed it within that way. So it can be really powerful in terms of practicing the thinking process. And that's what we mean by it not being repetitive, mechanical, and making sure that every 4 or 5 questions we do have a bit of a cognitive shock, so that children have really got to think and refocus. There are tons of different examples. We could have something like an odd factor times an odd factor always equals an odd product. An even factor times an odd factor always equals an even product. If that's what you want children to know, it's thinking through how can we design activities that support children to practice the thinking process, but to also practice in intelligent and really sophisticated ways. So in other words, what I'm trying to say is it offers a really systematic way of looking at maths exercises and really drilling down into what we want pupils to notice.
And that would be opposed to some of the banks of questions that I might have given 15 years ago, where, we are doing our 5 times table today, or we're doing our 3 times table today. So I'm just going to put some perhaps increasingly difficult, to my mind, calculations down for them to have a go at. But that would be about as far as it went in terms of thinking about variation and drawing attention to something with the questions that I was asking. I think when I started teaching, I would be thinking about drawing attention to them through what I was modeling or through what I was showing or just telling them. But as you say, John, the power in this is that there's little light bulb moments happening, hopefully, through the things that they're noticing as they're working through these carefully sequenced and carefully chosen examples.
Absolutely. And we've mentioned the five big ideas of teaching for mastery. And one of the things that comes in every part of those five big ideas around coherence, representation and structure, mathematical thinking, fluency and variation. And every part of that, it is children making connections. And variation theory is really the magic golden dust that allows children to make the connections. And really design tasks within that way, supports children with their mathematical thinking, supports children with their depth of understanding, but it also quite subtly shifts from it being a pure fluency activity to moving more into a reasoning and problem solving activity. So it's doing all of those three things, being fluent, reasoning, problem solving, in one fell swoop, to allow the children to make really deep and rich connections in maths.
Yeah, yeah, I totally agree, and totally on board with everything you're saying there. In my conversations working with teachers, and looking at lesson design and task design, and as you alluded to earlier, John, moving away from the idea of we've got these brilliant schemes, and they are brilliant and so helpful, and I wish I'd had them when I started teaching, because when it comes to things like variation theory, a lot of that thinking has been done for you as the teacher. Your job and task really is to understand what's been done for you, and so that you can, make the most of it and exemplify it. I would argue, and perhaps some children might need a little bit more of that, and therefore you can break it down even further if you want to. But some teachers will say to me, why does there have to be quite so much variation within a single lesson? Children are learning to do it one way, and then all of a sudden they're being asked to do it a different way, and then there'll be, out of the blue, another different way of doing it that they haven't seen before. And when does too much variation become a barrier rather than an enabler? And I'll ask you just to think about that for a moment. One of my responses is always, as the teacher, provided you know your class, but also you understand why the lesson has been structured this way, there are opportunities for you to draw attention to these models before the children, encounter them for the first time through the lesson. That idea of adapting the lesson structure a little bit, and making those decisions as the teacher, as the professional, I think is something that we need to get back to a little bit more. Since these schemes have been widely adopted, I think there's been a little bit of a over reliance, perhaps, on just following the structure as it's been designed. As I say, schemes are great. Wish I'd had them, but they've been written by somebody who doesn't know your class and your children at that point in time. And as you said earlier, John, you need to teach for where they are now, not where they should be prescribed by the curriculum or anything else. So I would always argue that it's worthwhile making adaptations. I think the risk can be that we dilute the lesson too much, or that we don't show certain variations because we're afraid that it might be confusing. What's your thoughts on that?
I think there's a few things within that, John. I think those five big ideas, it's important to say that they all work in tandem with each other. And so while variation is standalone in terms of its conceptual variation and procedural variation, it absolutely, as you've just alluded to, does link with representation and structure. And some schemes we know provide too many different models and representations to show the same concept. And so, when I'm working with teachers, colleagues, each day, my favorite button on the keypad is delete. And so we often go through and, think about which models are the most appropriate to reveal the concepts that is going to be taught. I would say any more than 2, maximum 3 per lesson is usually sufficient, and actually choose 1 or 2 models within your lesson and do them really well. And perhaps that there's something in having a staff meeting to thrash out where models begin in the early years, how they develop into key stage 1 and through to key stage 2. If you think of something like a tens frame, for example, that's introduced in the early years, but in lots of well-known schemes, they are continued into key stage 1 and right into year 6 and beyond. If you're thinking about, children generalizing that 10 tenths make 1 whole, when actually you could use a tens frame to demonstrate that in the exchange. So I think another kind of aspect of that is any more than 2 or 3 representations within a lesson, in my opinion, is leaning more into variety than it is variation. And the representations can absolutely work alongside variation theory. Let me just give you a really quick example. I planned a year 5 lesson fairly recently, and they were teaching children about decimal numbers, 2 decimal places. And one of the techniques that they were using was to trim down on the amount of representation. So we went for 2. We went for the use of a place value grid with tens and hundreds on it, and we went for a part whole model. Those are the only ones that we were using within the lesson. So we developed the lesson structure, and then on some of the slides, we had 2 tenths and 4 hundredths, and then the next one underneath was 4 hundredths and 2 tenths. So all of the children would have to say, there are tenths, there are hundredths, the number is 0. And that was their activity in the book. But then what it allowed the teacher to do for those children who do, finish quickly, get the concept quite quickly while they're working independently, it allowed the teacher to say, what have you noticed and what's the same and what's different? And really, they were drawing attention to the fact that it was the same digit, but they just had a different value. Now, for those children who were really understanding that at a deep level, they should be able, particularly in year 5, they should be able to reason about that verbally or make a few notes in their books about what it is they've noticed. And so quick and easy techniques can support all children in going deeper across the curriculum to really develop a depth of understanding. Now, that might be, as I've said, some children might just really get decimals. Others might need more support in order to understand them. But then when we come to looking at something like multiplication and division, actually, it might be the reverse. Those children who really struggle with decimals might be flying with multiplication and division. So it would provide opportunities through variation to allow all children just to go that bit deeper within lessons.
Yeah, thanks, John. I totally agree in terms of, as you say, that delete button being a particularly useful one, with the caveat that knowing, consistency in models and representations is really important as well as children move through the school. So as you say, having that chance to have a conversation with teachers in other year groups, and deciding on, actually, in our school, this is the model that's going to follow through whenever we're looking at anything to do with tens, with the tens frame, tens, tenths, whatever it might be. That I think that's a really useful approach, and giving teachers a little bit of freedom and autonomy to make those decisions and not be afraid to get rid of things if they feel that it's not appropriate, provided that there is some understanding of why it was there in the first place. I think is probably the thing. The bit I always go back to, and regular listeners will know, is going to bang on about division in year 4 again, but there's I always found that there was some pushback in year 4 with division, particularly because there's an easier way of doing it. There's an easier way. If we want just the answer, there's an easier, I can teach them short division in year 4 and they'll get it. What you're asking me to do, Mr. Cripwell, is you're asking me to, look at partitioning numbers, breaking them down, doing repeated subtraction and things, and trying to understand the structure of division. And my argument was, because that's what we want them to know, so that we know when they're going to year 5 and we're starting to look at long division or longer division structures, they've got that conceptual understanding of what division is. At this point in time in year 4, we're not valuing finding the answer as much as we're valuing understanding what's happening when we're dividing something, whether that's sharing or grouping. So that subject knowledge is really important, I think, isn't it, if you're going to make those sorts of decisions. John, the time is getting away from us as ever. If listeners want to know more, there is an entire chapter in your book dedicated to variation. It is, I'm just looking through your book now. Do you know which chapter it is?
I'd imagine it'll be the 5th chapter or the 6th chapter.
I think it's chapter 6, John. I think it's chapter 6. It's chapter 6, all about variation. Lots of beautiful illustrations and diagrams and things in there as well, and lots more examples of exactly what you've been talking about with us today. It's a really beautiful book. I've got a copy here. Teaching Maths for Mastery by John B. John, how did you come to write? Who's the 2 questions? How did you come to write the book, and who is it aimed at particularly?
So the book is aimed at teachers, new or experienced. It's predominantly aimed at primary teachers, but would be useful for maths leaders, schools, multi-academy trusts, just to have a look at kind of some of the overarching principles of effective teaching and learning in maths. Bit of leadership stuff in there as well, in terms of how to structure curriculums, and a lot around kind of what we've spoke about. In some ways, John, I feel like we've only just scratched the surface.
We totally have. Yeah, I completely agree. It's always the issue with this. And John, it'd be great potentially at some point in the future to come back to it, if that's okay, to maybe have another conversation around how variation theory might follow even more into task design, because I know that's another area that you're particularly passionate about. And you're right, we've only had time to pretty much barely scratch the surface of it. So thank you so much for joining us this afternoon, John. Is your website still the best place for people to catch up with you, mrbteach.com?
Yeah, everything's on there. If they want to contact me, have a look around, see what's available. Yeah.
And social media as well. I know we're connected on LinkedIn. I think you're on X as well, are you, potentially?
All of them.
Yeah. All of them, yeah. Everywhere you can be. Yeah, I know the feeling.
Full suite.
Yeah, it's a full-time job. I'm well aware. I really appreciate your time, John, this afternoon, and I know the listeners will take heaps away from it as well. Do look out for John's book if you want to know more about it, and hopefully we'll be able to speak to John again in the future, maybe looking at task design in a bit more detail at that point. Becky and I will be back on Friday for another Aftermaths episode, where we'll talk about our key takeaways from this brilliant conversation that we've had with John this morning. In the meantime, if you've got any questions, or if you want to send in your thoughts on variation theory or task design or anything else that we've talked about today, the email, as ever, is primarymathspodcast@twinkle.co.uk. That's Twinkle without an E. Or, as John says, you can find me on pretty much any of the social media channels. The full suite is available. Just drop me a message on there and we will discuss it on Friday's episode. John, thank you so much for your time today. Really appreciate it. It's been great talking to you.
Thank you for having me.
Absolute pleasure. If you're back in school listening to this, hope you have a great week, and we will see you on Friday.